Welcome to this CompTIA Network Plus video on the key networking concepts related to cloud computing and virtualization. In this video we will cover part 1.3 CompTIA Network Plus objectives, summarize cloud concepts and connectivity options, and we will explore network functions virtualization, NFV, understand what is virtual private cloud or VPC, network security controls, cloud gateways, connectivity options, deployment models, service models, scalability, elasticity, and multi-tenancy. Let's get started. Network functions virtualization, or NFV, is a transformative approach to network architecture that replaces dedicated hardware appliances with software-based solutions. Traditionally, networking functions such as firewalls, load balancers, and routers required specialized hardware to operate efficiently. However, with NFV, or network function virtualization, these functions are virtualized and deployed on standard computing hardware, offering greater flexibility and scalability. For example, a company running a traditional hardware-based firewall may find it expensive and complicated to scale. With NFV, or network functions virtualization, that firewall can be implemented as a virtualized service that can be easily expanded or modified to meet changing demands. One of the components that leverage NFV, or network functions virtualization, is the virtual private cloud, or VPC. A VPC, or virtual private cloud, is an isolated section of a public cloud where users can deploy resources with granular control over networking configurations. A VPC, or virtual private cloud, enables organizations to establish private subnets, define IP address ranges, and set up custom routing tables. Imagine a financial institution that needs to keep its customer database secure while still allowing web access to its online banking application. By using a VPC, they can ensure that sensitive customer information is stored within a private subnet while allowing the public-facing application to communicate with users. And to maintain a security with a VPC, or virtual private cloud, cloud providers offer network security groups. And these network security groups act like virtual firewalls that control inbound and outbound traffic. These groups operate by defining rules that specify which types of traffic are allowed or denied based on factors such as IP addresses, protocols, or port numbers. For example, a company hosting web application may allow HTTP and HTTPS traffic on ports 80 and port 443 while blocking all other connections. And this ensures that only legitimate traffic reaches the server while preventing unauthorized access. Another layer of security comes from network security lists, which function similarly to network security groups but are applied at the subnet level rather than individual instance level. A network security list consists of access control rules that define traffic permissions for an entire subnet within a VPC, or virtual private cloud. For example, a retail company running an e-commerce website may create a subnet specifically for the database servers and use a security list to ensure that only application servers within the VPC, or virtual private cloud, can communicate with the database, blocking all external access. And as organizations expand their cloud presence, they need reliable ways to connect their cloud resources to external networks. This is where cloud gateways come into play. An internet gateway, for instance, enables cloud-based resources to access the internet and accept incoming requests. This is essential for hosting publicly accessible applications such as websites and APIs, or application programming interfaces. Meanwhile, a network address translation, or NAT, gateway allows private instances within a VPC, or virtual private cloud, to access the internet without exposing their private IP addresses. For example, a company may need to run internal servers that download updates from internet but do not need to be accessed externally. A NAT gateway allows these servers to make outbound requests while keeping them hidden from the public internet. And organizations have multiple cloud connectivity options to establish secure and reliable connections. A virtual private network, or VPN, creates an encrypted tunnel between an on-premises network and the cloud, allowing remote offices to securely access cloud resources as if they were part of the same private network. For example, a business with multiple branches across different cities may use a VPN to securely connect all locations to a single cloud-based database. And for those requiring lower latency and higher bandwidth, Direct Connect services offer a dedicated physical connection between on-premises data centers and cloud providers. Unlike VPN connections or virtual private network connections, which rely on the public internet, Direct Connect provides a private high-bandwidth link that improves reliability and reduces network congestion. And as an example could be a media company streaming high-definition videos to a global audience. For instance, may use a Direct Connect to ensure smooth content delivery with minimal buffering. And now let's discuss cloud deployment models. And cloud deployment models define how organizations structure and access their cloud environments. A public cloud is a shared infrastructure where multiple organizations utilize cloud services provided by a third-party vendor. Public clouds offer cost-effectiveness and scalability, but may present security concerns for sensitive data. A startup, for example, may choose a public cloud to quickly deploy an application without investing in expensive infrastructure. In contrast, or on the other side, a private cloud is an exclusive cloud environment dedicated to a single organization. This model provides enhanced security, control, and compliance benefits, making it ideal for businesses with strict regulatory requirements. A healthcare provider handling sensitive patient data may opt for a private cloud to ensure compliance with data protection regulations. And next and third cloud deployment model is a hybrid cloud. A hybrid cloud combines elements of both public and private clouds, allowing organizations to take advantage of public cloud scalability while maintaining private cloud security for critical workloads. An online retailer may use a public cloud for handling peak holiday traffic while keeping customer payment data stored securely in a private cloud. And now let's discuss cloud service models. Cloud service models further categorize cloud offerings based on the level of management and control provided. Software as a service, or SaaS, delivers fully managed applications to end users over the internet. Examples include email services, customer relationship management software, and collaboration tools. With SaaS, users do not need to worry about infrastructure as the provider handles all maintenance and updates. Businesses using SaaS or software as a service solution like Google Workspace or Microsoft 365 can focus on their work without managing software updates and security patches. Infrastructure as a Service, or IaaS, provides fundamental computing resources such as virtual machines, storage, and networking. Organizations using IaaS, or Infrastructure as a Service, have control over the operating system and applications, while the cloud provider manages the underlying hardware. A video game development company, for example, may use IaaS or Infrastructure as a Service to rapidly scale their server infrastructure as demand fluctuates. Platform as a Service, or PaaS, offers development environment where users can build, test and deploy applications without managing the underlying infrastructure. Platform as a Service platforms provide tools, frameworks, and managed databases, enabling developers to focus on application development rather than hardware management. A software startup may use Platform as a Service to build and deploy web applications without worrying about configuring servers. Scalability is a crucial feature of cloud computing that allows resources to be increased or decreased based on demand. There are two primary forms of scalability: vertical scaling and horizontal scaling. Vertical scaling involves upgrading the capacity of an existing resource, such as increasing CPU or memory on virtual machine. Business running resource-intensive AI models may scale up its virtual machine to process data faster, and horizontal scaling, on the other hand, adds additional instances of a resource to distribute the workload efficiently. As an example, e-commerce platform experiencing a sudden increase in traffic may automatically spin up additional web servers to handle the load. And elasticity. Elasticity expands on the concept of scalability by automatically adjusting resources in real time based on workload fluctuations. Cloud platforms use elasticity to ensure that applications can handle sudden spikes in demand without manual intervention. A news website experiencing a traffic surges during breaking news events can benefit from elasticity, as additional computing resources are allocated automatically to keep the site running smoothly. And multi-tenancy. Multi-tenancy is a cloud computing principle where multiple users or organizations share the same infrastructure while maintaining logical isolation. In a multi-tenant environment, resources are dynamically allocated to different customers, ensuring efficient utilization without compromising security. An example could be a cloud-based customer support platform like Zendesk. It operates on a multi-tenant model where multiple businesses use the same infrastructure but house separate, secure environment for their data.